Hi guys, today we're going to cover section 3.2, the transformation of graphs of functions. Okay, and in this section we're going to cover how to move the graph up and down, left and right, reflection over the x and y axis, and also the vertical stretch. Okay, and later on I'm going to post the activity on Desmos, which it's actually it's a really good tool that if you know how to use. It's very user-friendly and I think intuitive. So give it a shot, take a try, and I think it would be good for you to help you understand how things move in this section. All right, let's get going. Okay, so if you look at number 2, the graph it's in green. Unfortunately, I have it in red, but just bear with me here. So we're trying to figure out what is the graph of f of x minus 4. Right? Now, I'm going to just bring you to the next photo and let's see what happens. Check this out. This is f of x minus 4. Okay? Oops. That should be n. Okay? So, notice, when you minus 4, we actually moved it to the right. Right? When you minus 4 is to the right. Okay? So, if you're looking in the book says, if you have f of x minus h, right, and h is positive, right, you move to the right. Okay. Now, what happened when h is negative? So when h is negative, so if you think about it, that means, for example, let's say negative 4. Right? So if h is negative 4, that means I have f of x minus negative 4, which is f of x plus 4. Okay? The way the book explains this, if you have x plus a number, we move to the left. Alright? But I think it'll be easier to think of this as a circle. If you remember what we did with the circle, with the center, the h and k, right, from the circle section, it behaved exactly the same way. Okay, it's the same behavior. So I'll let you chew on this for a second, but this works the same as the circle. Okay. All right. Part B. Part B, you have f of x plus 6. Well, let's take a look to see what happens. All right. So if you look at it, right, f of x plus 6 is in black. So notice how it compares from the red and black. Right? The red is our original. And it looks like plus 6 simply just raise the graph 1, 2, 3, 4, 5, 6. 6 units up. Okay? And be careful, right? This plus 6 is outside the parentheses and not inside the parentheses. Okay? So when the number, right, if you look in the book, and this is on page 309. If you have f of x plus k and k is positive, that means we're going up. If you have f of x plus k when k is negative, this means we're going down. So for example, if k equal negative 1, that means I have f of x plus a negative 1, and that means that's f of x minus 1. So this would tell me to go down 1. Okay, the book like to use the plus k and minus k, but I prefer just saying that when k is positive and negative. Ultimately, you can figure out which way makes more sense to you, and I don't really care which way you use, as long as you understand the idea and know how to use it. I mean, that's all that matters. So, and know how to demonstrate back to me, obviously. All right, next one. Well, we have graph of f of negative x. So again, the original. Now this time they're both in red. I probably should have picked better colors. All right, but check this out. Remember, f of x is y value, right? So when you put a negative in front of f of x, what you're doing is you are putting a negative in front of y value, or simply switch signs, right? And when you switch signs, what end up happening is this is a reflection over the x-axis. And notice, that's 1, that's negative 1. That's 4, that's negative 4. Right? And if you look at here, this is what? 9. And down here you have a negative 9. Okay, so essentially what you're doing is put a negative in front of it. That's a reflection over the x-axis. You switch signs on all the y values of the graph. Okay. All right. The next two, we have 2f of x and a 1/2 f of x. So we're gonna focus on the 2f of x first. Okay. All right. The 2f of x is in blue, and the original is still red. Now, I added a vertical line just to kind of show you the difference between the two. And check this out. When the vertical line x equal to 2 crosses, right, both parabolas, you could tell the difference by their y value. Notice, one is 4, one is 8. Right? So whatever the original is, right, the new graph is 2 times 2 times that. Let me take a sip of water. Okay? And that's not the only point. If you look at, say, right here, that's x equal to 1. So in this case, you got y equal to 1 and a y equal to 2. Right? So I think, so what happened here is when you put a 2 in front of the function, what you're doing is you're basically stretching it vertically, right? The stretching vertically also makes the graph seems narrower, right? It's like you're stretching it up, and you also make it narrow. Okay, so that's why you might have heard, like make it narrow or stretch. The idea, using different words, but the same idea. Okay. All right, let's move on to the 1/2 f of x. So if you think about 2, putting a 2 in front is going to make it stretch and make it narrow, right? So think about what's going to happen when you put a 1/2 in the front. All right, so this graph right here, again, you have the original, which is the red, and the green is the 1/2 f of x, and you can see that I use the same x equal to 2, that has not changed yet. And you can see that the green graph, the 1/2 f of x, all the y value is half of the y value of the original using the same x. Right? Notice here's a 2, here's a 4. Right? Okay. So in this case, right, when a number in front of the f of x, if this is between 0 and 1, we have a compression. It basically, you squish it down, right? It squish it down, you also make it wider. Okay, it widens the graph because you're squishing it down. Okay? So yeah, and the program I'm using is called Desmos, and I'm sure you can see it on the top of the graph. Desmos is actually a very good online tool, it is free. So if you have never used decimals before, I suggest you to give it a shot. And if you have used decimals before, no, feel free to keep using it. It's a great tool, and you only help. Okay. All right, let's move on to the next problem. And I apologize ahead of time for giving you guys such a blurry graph, but bear with me. That's the best I can do with the book. So, all right. So here we go. So we're supposed to graph f of x minus 2, right? So from the previous knowledge, right, if you have a f of x minus, this is a positive, right? So this means I have to take the whole function, move it 2 to the right. Okay? So that means every single point on here needs to be moved 2 to the right. So that means this point is now over here. This point is now over here. This point is now over here. And this point is now over here. And our new graph will look like this. Okay? We're just taking every single point and move it to the right. Now, don't worry about the segments, right? The segments will follow the points. So just worry about moving the points, and then we can connect the dot later. All right? Okay. So, now I'm going to erase this. And we're just going to keep working on the problem using the same graph. Alright, the next problem you have is negative f of x minus 3. Okay? So what do I do with this? Think about order operations. Order operations says you need to do multiply before adding subtracting, right? So which means I need to focus on this first, and then worry about this. Alright? So which means first thing first, I had to figure out reflection over x-axis. Right? Remember when you got the negative in front of the function, it tells you to change all the signs on the y, so that's a reflection. And then second, right, now when you have minus 3 on the outside of the function, that's up and down. So minus 3 means down 3. Alright, here we go. I'm going to use red this time. So first thing, actually not red, I'm using the same color this time. So first, let's reflect all the points over the x-axis. So 4 becomes a 1, 2, 3, negative 4. 4 becomes a negative 4. And 2 becomes a negative 2. And 2 becomes a negative 2. Okay. So if I just go ahead and do a flip, right? And that's what it's going to look like. All right, now let's see what's going on here. Now we have down 3, right? So down 3 means everything got moved down by 3. So I think I'm going to run out of room in this case, but we'll do our best. So now you have 1, 2, 3. 1, 2, 3. And now at this point you got 1, 2, 3. I'm going to run out of space. 1, 1, 2, 3. Okay, but to help, if you run out of space, that's fine. Just make sure you can tell me what the points are. Remember, this is 3, -2. This is -1, -2. This is -4, -4, right? So if you're going down 3, all you gotta do is just down 3. So this is 3, -5. -1, -5. Oh, I missed the point here. This is -1. Let's see. I forgot this point. This point is -2, 4. So this is -2, -4. So moving down 3, it will be -4, -7, and -2, -7. Okay, all we're doing, we're just moving up and down, left and right. Okay. Alright, looks like I got a lot to erase. Okay, third one. 1/2 f of x plus 1, right? So I'm going to go ahead and erase some of these. So we have a fresh graph. Okay, we're ready. Alright, so number 3, you have 1/2 of f of x plus 1, right? So first thing first, let's work inside the parentheses first. So this means x plus 1 means 1 to the left. Okay, so I'm going to move every point 1 spot to the left. Alright, so we're going to take all the points and move 1 to the left first. So -4, 4 becomes -5, 4. Every single point move 1 to the left. And then we're going to make 1/2. Remember, 1/2 means you take the y value, you multiply by a half. So which means the y value of 4 becomes now a 2. The y value of 4 now becomes a 2. The y value of 2 now becomes a 1. The y value of 2 now becomes a 1. So this is what our new graph will look like. Okay. Yeah, so make sure you know. So make sure you understand how this works, and you're shrinking the graph, stretching the graph, right? Make sure you know how that works. Okay. Last one. Well, I'm running out of space. F of -x plus 1. Okay. So let me erase this. Okay. Alright, so f of -x plus 1, right? Notice the x, there's a negative in front of x. So guess what that means? That means we're going, this is a reflection. So the negative in front of x is a reflection. Is reflection over, this is a reflection over the y-axis. Okay. So what that means is we basically flip everything over the y-axis. So this is what we have now. Negative 1, 2 becomes a positive 1, 2. Negative 4, 4 becomes a positive 4, 4. This point right here, the negative 2, 4 becomes a positive 2, 4. And 3, comma 2 becomes a negative 3, comma 2. So this is what our graph will look like. Okay. So then, plus 1. Right? Plus 1 means what? Plus 1 outside of the function means 1 up. So then we move everybody 1 up. And that is your final graph. Okay? This is something that you're not going to be able to do in the calculator. So it's much easier just to understand how the rule works, and then you should be able to graph this relatively easy. All right, let's go ahead and move on to the next one. Okay, the next one this time, right, same idea. This is a slightly different curve. This is a sine curve, so a somewhat modified sine curve. So, but let's figure out what we got. All right. So again, when we're moving left and right, up and down, we're just moving the points, some of the important points, and then we're just gonna connect the dot later. So in this case, right, x minus 3, you're doing this. This is positive. So we're moving 3 to the right. So that means this point now goes to, I'm going to just use the major points here. Every point gets to move 3 to the right. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I was saying 1, 2, 3. I can't count. 1, 2, 3. Yep. Sorry. Slight interruption. Okay, I'm back. All right. Where were we? Oh yeah, we're saying every point is basically just move 3 spots to the right. Okay. So the red dashed line is going to be what the graph looks like. All right. Let's look at the second problem. Negative hx. That looks like very similar to what we had earlier. Alright, so let me erase this. Erase all the red stuff. Okay. Alright. So again, negative hx plus 1, so we gotta make sure we do the reflection first, right? Order operations again. So this technically is a times. Right, so let's flip it over the x-axis first. So this point doesn't change, but this definitely changes, and so it looks like this. Notice the x-intercepts, they do not move, right? Because if you try to flip them, they're still on the line. Okay. All right, then plus 1. Plus 1 means everybody go up 1. So new point. Everybody go up 1. Everybody go up 1, up 1, up 1, and up 1. Okay. Now, for you guys that have taken trig or will take trig, this again happens in trig when you're shifting a tangent line, a cosine, secant, cosecant, sine line. So if you need to take trig, they haven't done it yet, keep this in mind. You're gonna see this again, okay? But if you've taken trig already, that means you have seen it before. So this should be fairly straightforward, at least easier, okay? All right, so that's it. The blue line is our answer. I'm trying not to erase it. Right? Basically, we flip it over and everybody move up by 1. Okay. Number 3, we have 2hx minus 3. Right? Notice I'm just kind of moving things around a little bit. I'm not getting too creative here. I think I probably should give you guys some more challenging problems, but oh well. We'll make it work. Alright. Now, you already knew what x minus 3 looks like, right? Because remember we had it earlier. It was 1, 2, 3. So everybody moves 3 to the right. That's what we had. Let me just recreate a graph really quick. And that's a curve, not a straight line. Alright. Okay. And now, 2. Remember what 2 in the front means? 2 means all the y value gets multiplied by 2. That's a vertical stretch. Okay? So, that means this is 3. Right? This is because the y value here, this is 2, 3. This 3 gets doubled because of the 2. So our new point is going to be 2, 6. This point right here is 1, 2, 3, 4. 4, negative 3. Right? The y value also gets doubled because of that. So my new point here is 4, negative 6. Okay? Now, these points here, their y values are 0. So yeah, 2 times 0 is still 0. So they don't move. So my new graph will look like this. The new graph looks like this. Starting at 1, 0, up to 2, 6, down to 3, 0, down again to 4, negative 6, and back up to 5, 0. Okay? Yeah. So definitely just a little bit of stretching on top and bottom, both sides. Both top and the bottom, both get stretched. Yeah, it's like pulling on the spring almost, right? Okay. Let me part D, last one. Now I got a lot to erase, so sorry. Just give me a little bit of time. Clean out the board, just like in class. Alright, what do we got? 4 is 1/3 h minus 2. I need to give you guys something to move to the left. I'm using too many minuses. Alright. Alright, so here we go. Minus 2 means 2 to the right. So let's do that first. 1, 2, 1, 2.